2.5 is on page 128, and that starts with the sum and difference formulas. This is a long section, so you gotta bear with it. Not hard, just long. So we have the following identities. We have the sum and difference of sine, cosine, and tangent. Sine and cosine you need to remember. Tan and cotan I provide. So if I take this, the cosine of an angle plus another, I notice it's cosine of the first, cosine of the second, sine of the first, sine of the second. Except I notice this sign is opposite. And if I look at the cosine of the minus, well, luckily it matches. Cosine of the two angles, that's cosine, cosine, sine, sine, and this is the opposite. When I look at a sine, sine of the sum turns out to be the sum, and sine of the difference turns out to be the difference, except sine of two angles added seems to be alternating. The plus you can get away with not worrying much about which angle comes first, but with the minus, the order is extremely important that you take the sine of the first and then the minus must go in front of the sine of the second. That order is very important. With a plus, you can get away with it. So nothing more than kind of applying those over and over. So the way I memorize them, I know that cosine is cosine of the sum of two angles is cosine, cosine, sine, sine, and switch the plus to a minus and the minus to a plus. With sine, they alternate, and I just have to keep track of what comes first, the sine of the first angle, and I think everything will fall into place. Tangent I provide, you really don't have to memorize. I'd like to look at a couple of problems and see how this works. I'd like to look at the following three problems and see if I could apply sine, cosine, and tangent. So if I start off with, oops, too high. If I start off with the sine of 105 degrees, well, 105 degrees is not a standard angle. I know about 30, 45, and 60, but since it has a 5, it's a good indicator that, you know what, I need a 45 in there. What do you add to 45 to get one of 5? 60 degrees. So it is important that I pick two angles. So, for example, 100 degrees plus 5 degrees is 1 of 5. That will apply on the sine, but I don't know what the sine and the cosine of those are. These are not standard angles. So 60 and 45 is not the only option. There are a couple of options you could do, but any one of them will do. By definition, this is the sine of the first, cosine of the second, and I'm reading right there, plus cosine of the first, sine of the second. So if I keep in mind that the sine comes first of that first angle, it's pretty good bet. And what do we know here? We know that at 60 degrees, sine is radical 3 over 2, cosine is radical 2 over 2, and cosine is radical 2, cosine is 1/2, and 45 degrees is radical 2 over 2. And again, like I mentioned in here, simplifying, you don't have to worry much about. I just need you to get the values, and we'll worry about that in our next half. So 1 of 5, again, I have multiple options. 190 degrees plus 5 degrees doesn't do me any good. So I'm thinking of 45 plus what? 150. That will work. There are other options, you know. It doesn't have to be. You could say, you know what? That's 135 degrees and 60 degrees. 60 I know, and 135 is the reference angle of 45. That will work. So based on the formula I have up for tangent of a plus, that would be tangent of the first plus tangent of the second divided by 1 minus tangent of the first times tangent of the second. And again, in this section, since simplifying this is very tedious, tan of 1 in the second quadrant, it's negative 1 over radical 3, and this is a 1, 1 minus, and you just copy those. And again, This is a fine answer for my students. You gotta check with your professor, see if they accept that or not. For me, that's good enough. Actually, I'm not starting a revolution. And I have my reasons. And I'd like to look at this problem. I couldn't find a problem, so I just made you one. Cosine of, and again, you gotta be careful. We want, so pi over 12 plus 6 pi over 12 will work, but pi over 12 is not a standard angle, so that wouldn't benefit me. I could also say 2 pi over 12 plus 5 pi over 12, even though this reduces to pi over 6, but this is a problem. 3 pi over 12 plus 4 pi over 12, that's one that works. Again, that's not the only one that works, because this is pi over 4, a standard angle, and pi over 3. So this is pi over 4 plus pi over 3. So this is a cosine of a sum. It's right there. So I know this is the cosine of the first, cosine of the second, minus sine of the first, sine of the second. It seems cosine is a bit easier to use if you remember to switch the sign. And this is radical 2 over 2, or 1 over radical 2. And cosine of 30, that would be 1/2. That 60, I mean, sorry. And that would be radical 3 over 2. Oh, that doesn't look pretty at all. Much better. And this will be radical 3 over 2. And again, for my students, you don't need to simplify in this section. Just get me this far, and me and you are very happy. And when I look at the following two problems, you're like going backwards, you know? So we moved forward, now we're looking backwards. We look at this, well, we're trying to eyeball which one has sine, cosine, cosine, sine. Wouldn't that be the sine? And if I remember correctly, always that order is extremely important, minus always that. And that turns out to be the sine of negative 60 degrees, which is negative the sine of 60 degrees, and that turns out to be negative radical 3 over 2. So, if I know the identity, the work is easy. You need to memorize those. And what happened when I see two cosines in a row? I know that's the cosine of what? If this is a minus of a plus, and here you can't go wrong because, you know, you take the first, you take the second, they are in order. That is the cosine of, what is that? 5 pi over 12 plus 7 pi over 12. Isn't that 12 pi over 12? Isn't that simply pi? And what's the cosine of pi, guys? Negative 1. And there it is. So if I get the identities right, memorized, and I know which one to use with which problem, then these should be really simple. Now we're looking at this problem. Well, this is the next batch of problems. They always want us to exact simply means do not use a calculator. Not that there's anything wrong with the calculator. We need to learn this because we need to apply it later on. So it says that cosine of theta equals a value, and they want the sine, cosine, and what does that mean? Well, let's see. If I highlight those, and I'll keep track of what is what. According to the sum formula, this is the sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. So if I really think about those in terms of alpha and beta, it seems for this problem, I want the sine and the cosine. They only gave me the cosine. And here in part B, it seems I need the cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And again, it seems I want the sine and the cosine of both of those. And here, this is a formula I provide for the tangent you don't need to memorize. You need to memorize sine and cosine. This is tan of alpha minus tan of beta divided by 1 minus tan of alpha, tan of beta. So again, it seems I need to know, to do this problem, I need the sine, cosine, and tangent of alpha and beta. We did something like this. That was done before. We've done that in the previous sections, right? And especially that the angle is unknown. So if I take this alpha, they're telling me that alpha is in quadrant what? They're stating that alpha is between 0 and pi over 2. So that means alpha is in quadrant 1. If this is alpha, and I know that sine is the adjacent over the hypotenuse. If the adjacent is radical 5 and the hypotenuse is 5, how do you find the missing side? We'll say the hypotenuse squared equals y squared plus 5. So y squared equals 20. And y would equal plus or minus the square root of 20. In this quadrant, isn't y positive? And that will be 2 radical 5. So, very good. And if I go for beta, it seems beta is between negative pi over 2 and 0. Negative pi over 2 and 0. This is negative pi over 2. This is 0. Beta is in quadrant 4. And there's beta right there. And according to beta, this is opposite over hypotenuse. Opposite hypotenuse, this is negative. We know that this makes this a positive 3. And now that I know those two triangles, pretty much I could do the entire parts A, B, and C one shot. And again, for my students only, you just need to substitute those values in. That's as far as I want you to go. You don't need to simplify any of those. If it's trig, you could leave it alone. And that would be my final answer. And how does that work? Well, I could break it up into two parts easily. I could say, you know what? As far as alpha, give me all of these values, and here they are. As far as alpha, it's right there. I need the sine. Sine is opposite over hypotenuse. And I need the cosine, adjacent over hypotenuse. Cosine, adjacent over hypotenuse. Sine, opposite over hypotenuse. And tangent is the opposite over the adjacent. And that's kind of what you do on all of those. And as far as beta is concerned, we need a cosine. Cosine is the adjacent over the hypotenuse. Sine is the opposite over hypotenuse. Cosine. So you notice you're repeating yourself over and over. The hard part is, and tangent is the opposite over the adjacent. The hard part is coming up with a triangle. If it's a standard angle, I know what these values are. If not, I could always sketch the triangle or use identities, which I don't recommend at all. We did that back in the days, if you remember, and if not, you could look back at the old problems that we did.